Hello students, we are going to study solid state. Okay, so solid state means we'll be studying about solids in this chapter, isn't it? So solid is a form of matter. Matter exists in three forms: solid, liquid and gases. Gases you have studied in class 11th, isn't it? Here now in this chapter we are going to study what? Solids. Okay, solid, if I say, what do you understand? This pen, if I am saying it is a solid, this chalk is a solid, okay? You are saying this, but how can we explain this solid? Actually, solids under a given set of temperature and pressure, okay, this should be there. Under a given set of temperature and pressure, they have got what? Definite shape, okay, volume as well as mass, isn't it? So if I am talking about this pen only, it is cylindrical in shape, isn't it? It has got mass, it has got volume, okay. Now, second is intermolecular distances are short. Actually, what happens when a thing will be in solid state? When its molecules or atoms will be arranged in very short distances. It will not consist of much space in between. If it will consist of much space in between, it will not have a definite shape, isn't it? Now, intermolecular forces are strong. If the atoms are too close, if the molecules are too close in case of solids, what will happen? Intermolecular forces will be more, and these intermolecular forces are only bringing it together, isn't it? So in case of these solids, intermolecular forces are strong because they are only keeping the atoms close together. Okay, now next, their constituent particles, atom, molecules and ions have fixed position and can oscillate about their mean position. Now suppose if I am talking about this chalk only, it is in the solid state, isn't it? So what happens, as the molecules, atoms or ions are so closely packed, it can't move here and there because space is not there. But yes, it can oscillate about its own position, isn't it? Because it doesn't have much space to move. So what happened? In its own position, it will move, it will oscillate. Okay. Now, they are incompressible and rigid. Okay. If I try to compress this chalk, okay, can we compress it? No. Why? Because the molecules are so close to each other that it can't be compressed. And if it can't be compressed, it is what? Rigid, isn't it? Now, two characters, intermolecular forces and thermal energy. These are related also with the solid state. Okay. If intermolecular forces are more, isn't it? What will happen? It will bring the molecules or the atoms or the ions close together. Okay. But what will this thermal energy do? This will, if we apply thermal energy, what will happen to a solid? Naturally, we are providing it energy, and as the result, it will affect the arrangement of the atoms, molecules and ions, and it will make it what? More apart. It will not bring it close together. So these two are opposite things. Intermolecular forces, they bring the atoms together, and here thermal energy plays a role in getting the atoms and molecules away from each other. Okay. So when we are talking about thermal energy and intermolecular forces, okay, they are bringing it close together. So at low temperature, it favors solid exist in a proper manner. It is favorable for it. Okay. Now these characteristic features which you have studied right now, you are studying from class 9th, class 7th also you have studied, class 9th also studied, class 11th also studied, but in class 12th you will study something more, something complex. Like solids, I said to write you, now I said about chalk, about pen, but there are some other solids also, like talcum powder. Okay, how we will be trying to define that with these properties. Okay, and other some complex properties of what solids, how it is arranged in the three-dimensional form. Okay. Now we are going to study amorphous and crystalline solids. These are two types of solids which you have to study. Okay. So when we are talking about amorphous solid and crystalline solid, you can see over here I had made the diagram of its arrangement. Okay, crystalline solid I have written quartz, amorphous solid also I have written quartz, isn't it? But here there is a difference, isn't it? Here I have written what? क्या difference है इसमें? यहाँ हमने लिखा है क्या? Quartz glass. Okay. Now, so let us study about the structure. You can see the arrangement of atoms in case of crystalline solid. Okay. Here long range and short range arrangement are there. If you are seeing this, this short range arrangement, this is what? A long range arrangement. Okay. Here also you can see the short range and long range we can take. Okay. So what is the difference between this crystalline and amorphous then? Okay. So actually in this, the short range as well as the long range, both are similar and they are in a regular pattern. But here, when we are talking about quartz glass, here short range is similar but long range is different, and this gives it a irregular shape. So when we are talking on a short range, it is also having a definite what shape. Okay, but if we are talking about the long range, no, it becomes irregular in nature. But this, it doesn't. Long range or short range, it remain in the same order. And as well as so, this crystalline has got what? A definite shape in short as well as in long range. But what happens to this amorphous solids? We say it is irregular because only in the short range it shows that it has got, yes, definite shape, but in long range it is not having. And this property only which shows that the short range arrangements are regular or definite in nature, this has been included in what? Solids. Okay. Now coming to the melting point. Okay. If you see about the melting point, you'll see what the melting point of the crystalline solids are. They are high as well as it has got a specific temperature at which it will melt. But what happens to the amorphous solid? What if it softens it with a wide range of temperature? Okay, how we can say? Because when you apply temperature, it doesn't have a specific temperature, okay, in which it melts. It melts in a wide range of temperature. Okay. Now coming to the cleavage property. Cleavage मतलब क्या होता है? टूटना. Okay. ठीक. Now cleavage, what happened? Cut with sharp tool into two pieces, it can generate in the two planes. Actually what happens when you try to cut this? Okay, you can cut this, okay, naturally, and you will be getting there new generate. It will be generating new planes, okay, when the crystalline solids are cut. But if we talk about the amorphous one, if you cut it, the two pieces into two pieces, what happens? You will not get regular surfaces. You will get what? Irregular surfaces. And this is due to the characteristic how the atoms are arranged in case of the crystalline and how they are arranged in case of the amorphous solids. Okay. Now, heat of fusion. What is heat of fusion? It is that temperature at which this solid starts what? Melting. Okay. So here when we talk about crystalline solid, it has got definite, okay, heat of fusion, temperature is definite, okay, and it is the characteristic of that crystalline solid, okay. But it irregular or in amorphous solids, you will see what? It do not have a definite what? Heat of fusion, okay. Now next topic is anisotropy, okay. In this you will see that crystalline are anisotropic in nature, these are isotropic in nature. This topic we will be studying in detail after this, okay. So just hold on this topic. Now we are moving on to what? The nature. When we are saying about nature, okay, this is a true solid. And here we are saying pseudo solid or supercool solid. Actually what happens? Why we are saying this true solid? It is having a definite shape. But what happens in this? We are saying it is a pseudo solid. You have seen the old buildings, okay. In that you have seen the windows of the old buildings. What happened? You will see that at the bottom it is thick, but above it is thin. Okay. So what has happened in it actually? Okay. Actually, because of the temperature, what happened? It is in the amorphous form, so what happens? It starts softening and it gets accommodated at the bottom, giving it a thick position of that glass over there, thick nature of the glass over there, and changing also milky in color. Actually it has flowed down from above to down. Okay, so these are known as what? Pseudo solid, because it has the property to flow, but yes, at a time come when it totally behaves as what? A solid. Okay, we are saying that it is a super cooled this amorphous. Why we are saying super cool? Because at low temperature, okay, they behave as what? Solids. Okay, now at a low temperature, I'll say super cool. If I am saying, then it means very low temperature. Okay, so now next, order of arrangement of what? The constituent particles. In this I said to you, it is arranged in the long range order, this is arranged in the short range order. Okay, so one question is asked in the exams, why the buildings of the windows of the buildings of the old monuments gets thickened at the bottom. The answer is that only because it is made up of what? Amorphous form of solid, and as the result what happens, due to temperature it flows and it gets accommodated at the bottom of that glass and it makes it thick in nature. Now we will be studying what? Anisotropic and isotropic. So I said to you we will be studying anisotropic and isotropic. Okay, so here you can see two structures on the board. Okay, this is of what? Amorphous, and this is of crystalline. I said to you the property of crystalline, that yes, it is anisotropic in nature, and amorphous, it is isotropic in nature. Now I am going to explain you this isotropic and anisotropic. See what happens in case of anisotropic in the crystalline form. We have seen that there is long range arrangement of the atoms, isn't it? And so what happened? It has got a fixed shape, isn't it? And here actually what happens in this, when we see it from different planes, okay, so what happened? It is not similar. Okay, you can see over here this plane, and you can see this from B to C, D to C and B to A. Okay, the arrangement is what? It becomes, it looks like what it is. When we see it, it is different from different directions. Okay, so as the result what happened? Its physical properties like refractive index and this resistance, electrical resistance, what happened? It becomes different when we see it from different directions. Okay, but what happens? And that property is known as what? Anisotropic. Okay, now isotropic. Okay, it is seen in case of what? Amorphous solids. Okay, actually in amorphous solids all the atoms are irregularly arranged. It has only got short range regular arrangement, and then in long range it becomes irregular in nature. Okay, you know that. So what happens here, when we see it from the different directions, okay, like you can see D and C, okay, B and A, okay, whatever directions you are taking, every time the arrangement is different, and so it is so different that at last what happens, its physical properties becomes what? The same in nature. Okay, it is not different. It is due to its so irregularity, okay, that when we synchronize it, when we see it at last, when it is summed up, what happens? Its property, physical properties become similar. So from wherever you want to take its refractive index or its electrical resistance, okay, you will get the same value. But this don't happen in anisotropic, okay, because here when it is seen from different directions, okay, here you can see this, the arrangement is different, okay, and as the result what happens, its physical properties becomes different when seen from different direction, and that property is known as anisotropic in nature. Okay, so this is all for today. Good day, take care.